Have you ever seen one of those massive container ships out on the horizon and just wondered, how in the world does something that big actually move? Well, today we're going to go deep, way down into the hole to uncover the absolutely incredible engineering that makes it all happen.
I mean, really think about it for a second. We're talking about a structure the size of a skyscraper, weighing hundreds of thousands of tons. This isn't a car. It doesn't have wheels. So how does it go? The answer is this amazing, totally hidden world of mechanical power.
And the heart of it all is the engine room. This is where you'll find an engine that is literally powerful enough to light up a small town. But, making all that power is only half the story. The real trick is getting that power from the engine and into the water. And that's the journey we're about to take. So check this out. This diagram is basically our roadmap. We're going to follow the flow of energy all the way from the main engine on the right through this entire chain of massive parts until we get to the propeller out in the sea on the left. All right, so our journey starts with what's called the shafting system. And this is not just one long metal rod. Nope, it's a series of gigantic interconnected shafts. Each one is forged from a single solid piece of steel, and each one has a very specific job to do. The very first piece of this mechanical puzzle is the thrust shaft. It bolts directly onto the engine. You can think of it like the very first part of a car's drivetrain. It takes all that raw spinning power, what engineers call torque, from the engine and starts sending it down the line. Next in line, you've got the intermediate shaft. You have to remember, on these huge ships, the engine room can be a really long way from the back of the vessel. So the intermediate shaft's job is pretty simple but absolutely crucial. It's a super long distance connector, just bridging that huge gap. And that brings us to the final link in the chain, the propeller shaft. Sometimes people call it the screw shaft. This is the piece that does something pretty amazing. It actually passes through the hull of the ship and connects everything to the propeller waiting outside in the water. Now, obviously, a chain of shafts this long and this heavy can't just float in midair. It rests on these things, huge shaft bearings. Their job is to hold up the incredible weight of the shafts, and this part is super important, to keep everything spinning in a perfectly straight line. Even a tiny bit of wobble could cause some serious, catastrophic damage. And just look at the scale we're dealing with here. Get a load of the size of that shaft compared to the person standing there. These are not car parts. These are colossal pieces of metal engineered with unbelievable precision to handle forces you can barely imagine. Okay, so spinning a giant shaft is one thing, but how does that spinning motion actually push a skyscraper-sized ship forward? Well, that's where a really, really clever device comes into play. It's called the thrust block. So here's the magic. When the propeller spins out in the water, it's not just pushing water backward, it's also pushing the entire shaft line forward with immense force. You can see this thick ring on the shaft here. That's called a thrust collar. That collar pushes up against these special pads inside the thrust block. And since the block is bolted directly to the ship's structure, bam, the entire ship gets shoved forward. Yep, its whole job is to be the bridge that takes the incredible force from the propeller and transfers it into the body of the ship. Without it, the shaft would literally just try to launch itself forward right out of the engine. This single component is what makes the ship move. And here's what one looks like in the real world. That massive, chunky white housing, that's the thrust block. You can see it's bolted down with these enormous fasteners, straight into the foundation of the ship. It has to be unbelievably strong to take that constant, powerful push, 24/7. Okay, so we've got power, we've got spinning shafts, and we have a way to push the ship forward. But that leaves us with another giant engineering problem. How do you run a massive spinning shaft through the bottom of the hull without, letting the entire ocean pour in and sinking the ship? The answer is something called the stern tube. As you can see right here, it's basically a sealed, perfectly lubricated tunnel that lets the propeller shaft pass safely out of the ship and into the sea. It is, no joke, one of the most critical components on the entire vessel. And it has two jobs that are both absolutely vital. First, it has bearings inside that have to support the insane weight of that gigantic propeller just hanging off the back of the ship. And second, its super complex system of seals is the only thing preventing millions of gallons of seawater from flooding the engine room. And what's really cool is there are two main ways they do this. Some systems are actually water lubricated. They use a special kind of wood that gets slippery when it's wet, which is pretty wild.
Others are more like what you'd expect. A sealed system that uses oil and a whole bunch of heavy-duty seals to keep the oil in and the water out. And that finally brings us to the grand finale of our journey, the part that actually gets its hands dirty, meets the water, and does all the work, the propeller. All of that incredible machinery we just saw, the engine, the shafts, the thrust block, it all exists for one reason, to turn this. As the propeller spins, its precisely angled blades are designed to literally bite into the water, throwing it backwards and creating that powerful push forward we call thrust. And again, the scale is just mind-blowing. This isn't some little propeller from a speedboat. These things are giants, cast from bronze alloys, weighing many, many tons, with each single blade towering over the people who build them. It's just a stunning feat of engineering. So, let's put it all together. The journey of power in 4 simple steps. 1. The engine makes the spin, the torque. 2. The shafts carry that spin to the back. 3. The propeller turns that spin into a powerful push or thrust. And 4. The thrust block takes that push and moves the entire ship. Simple, elegant, and incredibly powerful. So next time you see one of those giant ships gliding by, remember that you're only seeing the tip of the iceberg. Down below the waterline, there's this hidden world of massive, powerful, precise machinery making it all happen. It just makes you wonder, right? What other incredible engineering is humming away, just out of sight, powering our whole world?